Edexcel Core Pure, Hyperbolic Functions 1 and Introduction. Solving simple equations. So some equations that involve hyperbolic functions can be solved by making the substitution back to the definitions of sine, cosh and tanh involving e to the x, and then manipulating the equation to get the required result. So in this example, we'd like to solve cosh x equals 3. There's more than one way of solving a problem like this, and in future videos we will look at how we can use inverse hyperbolic functions. But for now, I'm just going to use the standard definition of cosh x. That's e to the x plus e to the minus x over 2 equals 3. So we want to solve this for x. So a little bit of rearranging. You may have seen equations like this before, but if you haven't, there's a very neat way of dealing with this, and if we multiply all the way through by e to the x and see what we get. Now hopefully you can see that this is a quadratic in e to the x. So if I put everything on one side and make it a little bit clearer, so we have a quadratic in e to the x, and I can solve this now, for example, by completing the square. So e to the x minus 3 all squared minus 8 is 0, and then we can start to solve for e to the x. I could have used a quadratic formula as well, and I would have got to this form. Okay, so I've got e to the x is 3 plus or minus 2 root 2. Therefore, if I put it back into a logarithmic form, x equals the natural logarithm of 3 plus or minus 2 root 2 are the solutions to the original equation. So using that standard definition of cosh x is a very helpful way to get into equations like this, and being able to manipulate it into a quadratic form is an extremely neat thing to be able to do. Once we've solved that quadratic, we get two solutions for e to the x. Something to note here is we do have two solutions, and this solution can be written in a slightly different form. It can be shown without too much effort that 3 minus 2 root 2 is exactly the same as 3 plus 2 root 2 to the power minus 1. So if we look at the natural logarithms of these two things, we could apply a power law now and put the minus 1 at the front of this logarithm. In other words, you could write this solution as x equals plus or minus ln 3 plus 2 root 2. So the nice symmetrical solutions for x are a bit more obvious now, and we can see that we're looking for the plus and minus values on the graph. So this equation is a little bit more going on here. We've got to solve cosh x plus 2 sine x equals 3, but again, using your standard definition of cosh x and sine x will allow us to present this equation in a form which can be solved. So cosh x becomes e to the x plus e to the minus x over 2, and we're going to add on two lots of sine x, e to the x minus e to the minus x over 2 has to be 3. Multiplying all the way through by 2, and let's expand those brackets. And then if we collect terms together, collecting like terms, we're going to get 3 e to the x minus e to the minus x minus 6 is 0, putting everything on one side. And again, just to make things a little bit more transparent, look what happens when you multiply through by e to the x. We get 3 e to the 2x minus 6 e to the x minus 1. I've rearranged it as well so we can see this nice clear quadratic form. I'm going to use a quadratic formula this time. So e to the x, so I've got a, b and c, so e to the x is minus b plus or minus the square root of b squared minus 4ac, which gives me a plus 12 over 2a. So I've got root 48, which can be written as 4 root 3 over 6. Or if you preferred, you could write this as 1 plus or minus 2 root 3 over 3. So this could be solved on a calculator, or we could just go on to a logarithmic form. If we are going on to a logarithmic form, notice that e to the x has to be positive. So if e to the x has to be positive, then that negative root is invalid, and we would have x equals the natural logarithm of 1 plus 2 root 3 over 3. So there is one valid solution in this question for x. So picking out some of the key details there, the definition of cosh x and the definition of sin x allow us to get into this problem, and then multiplying through by e to the x creates this very helpful quadratic, which then can be solved for e to the x. But we do need to be a bit of care here, because e to the x we've seen must be greater than 0. So when we go to the solution for x, we only have the positive root. And if we look at this graph of cosh x plus 2 sin x equals 3, we can see that there is only one solution for x. In the next video, we're going to be looking at hyperbolic function identities.